Hello and welcome to the video on setting up a gRest or Koios node for the Cardano blockchain. We're going to cover everything, the whole setup from scratch, starting with this little presentation about all the components involved and what exactly we'll be doing in the rest of the video. So let's get started. Here's the overview. First in the list is ZFS. We're going to cover what it is and how to set it up on Ubuntu. I'll be using Ubuntu as my operating system for this video. Next up is Cardano-node, the component for syncing the Cardano blockchain. We will cover the setup on the preview network, which is one of the testnet networks, and we'll also use Mithril to get the snapshot to make the syncing very fast. We will deploy it as a systemd service, and basically all the deployments that we do in the video will follow the guild operators documentation and the recommended way of deploying things. Next up is cardano-db-sync. For it, we will need a PostgreSQL database, so we'll cover the setup of that. We will also cover snapshot restoration for cardano-db-sync, which is kind of like Mithril for the Cardano node, basically reducing syncing times. Also, we're going to deploy it as a systemd service. And then finally, we have the gRest or the Koios node deployment. So we'll cover what exactly gRest is and how to deploy it. So ZFS stands for Zettabyte File System, developed in about 2005, and features data integrity, scalability, advanced storage management. We don't want to get into the details of ZFS in this video. This is not the goal, but the most important part is that it improves performance for gRest nodes. So that's why we will be setting it up. It's not a necessary step. It's sort of a zero step, an optional one. I will be covering it because I know that performance does improve in terms of read-write operations, and also it uses compression, so it takes up less space, which is important when you are dealing with a database that is of size as the Cardano blockchain, which on mainnet can be, I don't know, now it's probably around 400 gigabytes. Okay, next up, Cardano node, the core component of the Cardano blockchain. It's written in Haskell, and it's a prerequisite for cardano-db-sync, because Cardano node is the component that communicates with other Cardano nodes, and that's how consensus is reached. That's how blocks are put on the blockchain, and that's how also cardano-db-sync gets information to sync to the database. It gets it from the node. So cardano-db-sync, component that follows Cardano node, like I said, and stores blocks and transactions in a Postgres database. It is also written in Haskell, and this in hand is a prerequisite for gRest or the Koios node, because gRest is basically an API on top of this PostgreSQL database that cardano-db-sync is syncing with some enhancements. So finally, gRest or Koios is a decentralized and elastic RESTful query layer for exploring data on the Cardano blockchain. So like I said, it sits on top of the PostgreSQL database that cardano-db-sync creates. In addition to Cardano node and cardano-db-sync as required components of the setup for gRest, it's composed also of Postgres and haproxy. Postgres is also an open source software, basically a REST API that can be put on top of a Postgres database. It is also written in Haskell, and it's a very, very cool software for a REST API. haproxy is high availability proxy, and in gRest it's used for routing requests and basically making health checks against gRest instances. gRest is the open source software used by Koios. So why am I saying gRest, Koios? What is the difference? So strictly speaking, gRest is the software that we'll be setting up. So we'll be setting up a gRest node basically, and it's called gRest because REST because it's a REST API, and G stands for Guild because this software was developed by the Guild operators. On the other hand, it is used by Koios. Koios being the decentralized open source API, Koios is more like an organization that is using the open source software and is also developing the software. So just to make those two terms clear, you can refer to Koios node as gRest node. It doesn't really matter. Finally, here's an overview of the Koios or gRest design. This is basically Koios design, not gRest. But we have on the top level here the DNS routing. So this is where the API requests from clients come in. And here there is a separation between lightweight clients and heavyweight clients. The separation is basically lightweight clients don't make a lot of API calls, while heavyweight clients like explorers and wallets do a bunch of calls, and basically they need special rules to allow them to make such a huge amount of calls. But for either of them, the flow is pretty much the same. So it hits the top level DNS routing. It then this is the so-called monitoring layer. The monitoring layer is running the health check services, which are checking all the instances in the network to determine whether they are healthy or not. So the API request received by the DNS will always be rerouted to a healthy instance. That's why gRest is an elastic layer, or Koios is an elastic layer, because an instance, it's very easy for an instance to join this network. And it's also decentralized because anyone can run these instances. It's not a single provider running all of them. So any individual can set up an instance and join the network if they want to. And that's about it for this presentation. Now it's time to get into the server and start setting everything up. All right, I got a fresh server here, logged in as root. There's nothing on this server whatsoever. So first thing we're gonna do is just create a separate user that we're gonna be using for all of this. And that's gonna be, I'm gonna call it Koios. So I can use the add user Koios command and set the password and all the other fields, which I don't need to fill out now. That's about it. This user is also going to need sudo privileges, so we're gonna add him to the sudo group with user mod. Add to group sudo user Koios. Okay, and that's about it. So we can now switch to this user. We can see that we have sudo privileges by just echoing sudo, and if I type the password, I'm sudo. Okay. Now, if I wanted to set up this server, I would go through setting up SSH login for this user with the keys and so on. But you can check some other videos for that. I'm not gonna go through it now. Anyway, that's our first step. We have the user, and so the next step is going to be setting up ZFS that we talked about earlier. So this is the OpenZFS documentation page, and I'm using Ubuntu. So I'm just gonna go there. What do I need to do to set up ZFS? There are two ways. So the ZFS you can set up as a file on your server and turn it into a ZFS file system, or you can set up root on ZFS. Now I'm gonna just create a file and use that as the file system. You can opt for the root on ZFS option as well. So here you need to have the universe repository enabled in the sources of your apt package, right? So you may need to add this line to your sources list with the code name being the code name of your distro. I know that this server already has Universe enabled on this server, so I just need to run these two lines to install the stuff. And okay, so I need to run with sudo and do update. And so sudo apt install ZFS utils Linux. Yes, it will need to install some other packages as well. Fine. So once that's done, we can check that we have the zpool command and ZFS command. Okay, so both of those are available now. So we got ZFS, and now how do we make this directory and set it up as a ZFS file system? First, we need to pick where it's going to be. I'm going to use the opt directory, and I'm going to create this opt Cardano. So when we will deploy things, this opt Cardano is a root directory for deployments using the guild documentation. So I'm just gonna follow that and create it this way. I need sudo, and then if I ls opt Cardano, I will see that sudo is actually the owner. Or if I do it this way, it's clear. So root is the owner, so I will need this folder to be owned by my own user, which is Koios. So I'm gonna own the directory with ch own Koios opt Cardano. Okay. Now the Koios is the owner of that directory. Okay, so I'm gonna put what I need to do is put a file, basically an empty file that just has some space, the amount of space that I want to give to ZFS, and then turn that file into a file system. So I'm gonna use the dd command for that, which is just copying things over, and it has two arguments, if, which is the input file, and for the input file we don't really have input, so we just want to use dev0, which will just copy zeros basically into the file, and the other argument is of, which is the output file, and that's going to be then opt Cardano, and we're gonna call this file the disk 000 as it's like a file system disk. We have BS then 1 megabyte, which is like the chunks, how many the size of the chunks to copy over, and the count, which is how many. So this is what you need to adjust when you do this. I'm gonna set the count to 109600, which is around 100 gigabytes. And if you're doing this on mainnet, you will need more. On mainnet, it's recommended to make the partition with at least 600 gigabytes to have enough space for the increased size of the database and the node DB and the ledger and so on. For preview net that we'll be using, this should be enough. So it's going to take a while to copy 100 gigabytes of nothing over. And then we're going to create the ZFS file system with the zpool and ZFS command. So zpool is going to create the so-called pool in the ZFS vocabulary. And then we're going to use that pool as the mount point of the C node directory that's going to be filled out later on. So let's just wait for this to finish. Okay, that's done. So now we can go ahead and use the sudo zpool command with the create option. So create the zpool, we'll call it Koios disk, and the input file that we're gonna create it from is opt cardano disk 000 that we just created. Okay, that's the first thing. Now we have the pool, and now we need to use the ZFS to set a mount point. So set mount point equals mount point is a point in our file system. So we're going to use opt cardano, and then we're gonna use this cnode directory where basically all our big data is gonna be in. So that's the best directory to make use of the ZFS. So this is going to include all our Cardano node data, all our Postgres data from db-sync, everything. So we set the mount point to this C node, and then we tell it which disk to use, or which pool to use. So Koios disk, we do this, okay. And then the last thing to do is to set the compression mode. So we set compression to use LZ4. You can check the ZFS compression options. I think LZ4 is the best one in my experience. And that's about it. We now have set up this ZFS disk. We can check zpool list. We see that Koios disk has a total of 107 gigabytes, of which 170K is allocated, so nothing. And also ZFS list will show us that Koios disk is mounted on this mount point C node. Great, ZFS done. Next, we need to deploy cardano-node. So like I said, okay, actually, before we go into cardano-node, we are deploying Koios, right? So we need to check, because Cardano-node is required by cardano-db-sync, and Koios requires cardano-db-sync. So Cardano-node and cardano-db-sync have to be in compatible versions. If you look at the Koios release pages, then every version of Koios is going to tell you which versions of the components you should be running for this to work properly. So in this video, we're going to set up the release candidate, the current release candidate for mainnet, which is Koios 1.1.1. And here you have a lot of information, actually, even instructions for instance providers, which is kind of us. So the most important thing is to set the db-sync and node version to compatible ones. At the time of recording this video, as you just saw on this release page, the node version was 8.7.3 and db-sync was 13.2.0.1, and this has now been updated, as you can see, to these versions. So make sure that you pay attention to this. Like we said before, when you want to set up the node, check the release pages, check the compatible versions, and install those. So in the video, the recording is with the old versions, but this doesn't really change at all. All you need to do is update to a different node version. The process is exactly the same. So from the documentation of the guild operators, we're going to use the standard deployment from the master branch, which is deploying the node 8.7.3, so that's fine. And then later we'll use this db-sync 13.2.0.1. Really important to get these in sync, because if Cardano node and db-sync don't work together, nothing's gonna work after that. Basically, you won't be able to start db-sync as it's incompatible with the node version. All right, so how to set up the node? Well, this is pretty simple. We'll just follow the documentation from the guild operators. First are the basics, which is this guild deploy script. We can just copy all of this over. It's gonna download this guild deploy script that's going to set up the file structure and do some other things, including downloading the Cardano-node binaries for us and maybe db-sync even. Let's see. So yeah, we can look at the usage of this script with, I think maybe just -h. So we have the network argument. We're going to select which network we are connecting to. We're going to use preview right now. The parent folder, if you want to change, so the default is, like I said, opt cardano is the default folder, and then C node is going to be the default name of the node, which is the opt cardano C node will be the full path. The branch you want to use, so default is master. We're going to use the default. Skip update of this script itself. We don't need that. We already have the latest version. And then selective install. So here the script installs different things. Also some prerequisites for actually compiling the Cardano binaries, which we don't need. So most of these are like default skip, default skip, default skip. And then we have the download binaries for Mithril signer, Mithril client. Okay, we're gonna use that. So we're gonna use M force override. We don't need that. That's basically for redeployments. And then download release binaries for Cardano node, Cardano CLI, and cardano-db-sync. Also, you have the option for CNCLI, Ogmios, and so on. We can download Ogmios, but I don't think we'll be setting it up. So yeah, that's it for the usage, and we can run it with the options that I said. So I'm gonna use branch master, although this is a default, so I don't really need to specify it. But just to be clear, network is going to be preview. Yeah, so we said T is for the top level folder, which is C node. Also, this is the default. I'm just like showing you the usage. And then selective install is going to be, so we have Mithril, we have the binaries. I actually forgot, let me see. So we have M, we want M, and we want D for the binaries. And I guess we should install P, which is the prerequisite for most tools on this repo. So maybe best to install that as well. So guild deploy, basically, like we said, branch master, network preview, and then, okay, top level C node, not necessary, but still S, and then we'll use PMD. Right, so P is prerequisite, M is Mithril, D is the download the binaries. So we're going to download the binaries so that we don't have to compile them, because compiling takes a long time. So this script is going to take a while, depending on the options and depending on how many prerequisite packages are missing from your server. But yeah, we just need to wait for it to finish, and then we should already have the Cardano node binary set up. So let's just give it some time. Okay, so that's done. We can see the output here, downloading Mithril, downloading Mithril signer, downloading Cardano node, cardano-db-sync. Okay, great. So we can check the versions. Well, first we need to refresh our environment. I would know the the guild deploy script writes some stuff to bashrc, some environment variables that we need to refresh. so that we have now Cardano-node binary in the path. And if we check the version, see that we are on 8.7.3. That's good. We also need cardano-db-sync, and we check the version, and it's 13.2.0.0. So this is not the right one, because we need 13.0.2.0.1. And yeah, we need to keep this in mind. When we get to db-sync, we'll need to change this binary to the patch version of 0.1. But okay, just understand the node version is correct, so we can start the node and do all the syncing. That's fine. So the script creates this cnode home variable that's convenient so that you can use, and it resolves to this opt cardano cnode directory. And here we have different things. We have the files which contain files for the Cardano node, Genesis files, config files, also a db-sync config file. We have the scripts which contain a lot of scripts. So cnode.sh for running cnode, Mithril client, a Mithril signer, setup gRest that we'll use later. This is basically to the final step of setting up Koios. db-sync.sh for running db-sync, and that's about it. We need guild live view to check how the node is doing. Yeah, okay. So what we want to do, if we started the node right now, it would start syncing from scratch and it would take a while. And we have Mithril to basically get a snapshot and make the syncing really fast. So how do we use Mithril? It's very easy with the guild setup. So like we saw, there's a script called Mithril client. And if you check the docs, you have scripts, Mithril, then you have the overview here of how Mithril works. I'm not gonna get into it, but the main thing is it provides snapshots that are signed by operators on the network based on stake. And you have the signer if you want to run a signer. So basically to provide snapshots, and you have a client that just can take the snapshots and download them. So if you look at these docs here, you will see the usage Mithril client environment setup. I think this is a bit outdated because these are not the arguments for the script to work properly, but we can still use, we can still, okay, if we run the script, we will see that the usage is -d and -u. So we can, so -u is to update the environment file, which seems to be this step, right? Create the environment file that's going to do it. And this is going to automatically get the snapshot that's right for our node version, because there could be many of them. So we don't really need to care about anything. The script will do everything for us. Client will say, okay, -u to update the environment file and also download the snapshot at the same time. So see, when it starts, it's going to say Mithril environment file not found because we didn't create it. So we created successfully. DB directory is empty. Yeah, preparing snapshot download, and we are downloading the snapshot right now. So you see it's quite fast. It's going to be like 1 minute, and our node is going to be up to the tip, rather than, I don't know how long it would take on preview. On mainnet it would take many days to sync from scratch, and basically you really don't want to be doing that. So yeah, that's a quick demonstration of the Mithril functionality in general for Cardano, and specifically how the guild docs and the guild script do it for you. It's very nice. So we see cardano-db is downloaded. Now it's already unpacked. Something's going on in the background. Basically, it needs to download it, needs to unpack it and get it ready for your local node to use. So we just need to wait for that to finish. Okay, done. So cardano-db has been unpacked, successfully checked against Mithril multi-signature, and files in the directory of the cnode-db can be used to run a Cardano node with version higher or equal to 8.9. This is basically wrong. The snapshot will work with our version, which is 8.7.3. It's just a bit weird how Mithril sends messages and stuff, but everything is fine. The snapshot will work, or well, should work. Let's see. We have the snapshot of the node. So now we just want to start a node and have it run. So we saw there's a cnode sh script that we can start, and it should start a node. And here is a lot of logs about the configuration of the node that we just started. So you see which topology file we are using, which database file, probably which config file, or at least like the config that's read from the config file is all printed out here. And last line is listening on the node port, which is all good. It means the node is running. So no errors, it means the node just works. Also, if we look at this directory logs, then we'll see there are some logs printed in the node JSON. So just because there's no output here doesn't mean that it's not working. Like logs are actually printed here. We can look at just the tail of this node.json. And we see diffusion, okay, user interrupt, connection manager. Okay, these are just node logs. We're not going to get into it. But the node seemed to be working. So what we want to do now is to deploy it as a systemd service. And the cnode script has this flag -d to do that. So we can deploy the service, and you see that it created this systemd system cnode.service. So we can check the status of that. It should not automatically start just by doing this. Sorry, systemctl. You see Cardano node is inactive. So we can restart it, right? Restart this service, and now we check the status. It's running, and the last log line is listening on, so that's fine. Seems to be working. And if we do the tail command again for our logs, and we say -f to follow them as they are printed, then we'll see logs are coming in. I saw a message there for current block, so chain sync event. Okay, it's all good. It's syncing. We can also check guild live view script for a UI overview of what's going on with the node. We see which epoch we are on, 541. It's quite a large number, but on preview, epochs last just 1 day. So the tip difference is how far away from the theoretical tip the node is. Anything under 100 is like acceptable. So this looks fine. Some peer-to-peer information. And yeah, in terms of the node, everything looks fine. We have a syncing node, and that's our prerequisite for db-sync done. So the next step is setting up db-sync to listen to the node output and sync everything to the Postgres database. So let's start by looking at the guild docs for db-sync. In the build and run, we have db-sync, and it says, okay, we need to sure the prerequisites are in place, which are just the guild deploy script that we already have, which is basically Cardano node. So cardano-db-sync relies on an existing PostgreSQL server. So we need to set up a PostgreSQL server before we run cardano-db-sync. Also, note cardano-db-sync uses a lot of memory and basically has a lot of requirements. So you can look at here for mainnet. Here is listed 32 gigabytes of RAM, but 48 should kind of be the minimum actually. You have to consider you need RAM to run the node first and then db-sync. So for mainnet, the requirements for the server of the machine are actually pretty high. Also, IO operations should be high. 60K would be great, but if you have low IO, then sync times could be slower. And yeah, this storage is takes a lot. That takes a lot of space. On preview, it shouldn't be so much. I think the whole database, the Postgres database on preview is around 20 gigabytes, so not that bad. But on mainnet, if you want mainnet, then all the requirements go up significantly. So keep that in mind. And okay, what we want to do is look at this sample Postgres setup. We even have this appendix of a sample setup that we can use in the guild docs. So basically, we can just copy this command and we will install Postgres 15. The latest version is 16, but we'll just use 15 since that's what's used on the Koios nodes. We copy this in, and we should get Postgres installed. Anyway, we now have this PSQL binary. So if we use that, we say, okay, now without arguments, it's not going to work because it's using some default arguments to log into the database. But importantly, Postgres is installed since we have this binary. So what's next? We need to set up a user. So here are the instructions. Here's echo who am I. So that's just going to give us the current user. And then Postgres, when you install it, creates this default Postgres user on the server, and also a Postgres default database that we can use. So we can switch over to this user, then log into the Postgres database, and then create our own user with a password, and then we'll create this pgpass file so that we don't need to enter a password or anything when we want to log into our databases, because this user role will be a super user, so it can just log into anything. So we switch the user to Postgres. Okay, we say PSQL. By default, it's going to use the username as the database name. So it's going to log into this database Postgres. And we see we are using version 15 of Postgres. PSQL is version 16.2, but the actual version of the database is 15. Okay, and now we need the create role. So we do create role, and then our user is Koios, super user, right? That's super user login, and syntax error. Sorry, we don't need the quotes. We just say, yeah, create role Koios, and then we set the password by using alter user Koios set, no, not set, just password. And here we need single quotes, so I'm just gonna use Koios as my password, and alter role, that's fine. We can leave here. So we now have a super user role in Postgres. So if we go back to our Koios user, if it's gonna work, yes. Yep. Okay, we have our super user. So if we create this pgpass file now, so we export this variable pg pass file to this pg pass, and then we echo this init var run postgres, the port, the C Explorer database that's going to be created by db-sync. That's fine. Anyway, this pass file now should allow us, so from the Koios user, to log into the Postgres database without any prompts and without any errors. Okay, so that works. We can leave that. And that's it. The only thing I'm gonna do is also, so we had this export pg pass file. I'm gonna add this line to my bash rc. So that I just have it in the env all the time. And okay, I can refresh my env, and I know that now I have pgpass file. And if I relog into the server or reload the user, I'll always have this variable set. Okay, so that's basically the sample database setup. We have access, everything is working. Now here comes the tuning of the Postgres instance. So the tuning is quite important because it improves performance a lot. Here on the guild docs, so these are related to gRest nodes, and there are some here below 3 settings that are sort of mandatory must have, like these are will help you the most, and it totally makes sense to have these set because of the nature of db-sync. So wall level is like right ahead level. Basically we are not affected by loss of volatile information and on restart, so we don't really care about data retention and stuff because db-sync will always be syncing the chain, and some blocks need to be deleted and so on. And on restart, we don't care about data retention. So this will improve performance a lot with no drawbacks. And here is the setup, typical Jira setup. Here is the best common setup, but I think this is relating to mainnet. Yeah, so you have a setup that has 64 gigabytes of RAM, 8 CPUs, and so on and so on. You can test your IOPS with this command. It's an interesting stat you might want to see. Okay, so this is like a common setup, but there's also this website pgtune that you can use, and it will give you some stuff. So for gRest, you can select online processing, online transaction processing system as the best use case of the database. So you input some parameters of your setup, and then you get an optimized setup of Postgres that you can use. So total memory in RAM, let's see, this server has 16 gigabytes of RAM, well, 15. So 2 gigabytes of RAM are already used by the node that's running. Some of it is going to be used by db-sync as well. So what's left for Postgres is I'll put a safe number and say 8 gigabytes of RAM. A number of CPUs, same thing. So we have 4. So this is an optional stat, and I guess I just won't even put it in. Number of connections, I think you can use this number suggested in the docs, 200 as a good number if you are serving the API. If you are running it locally just for yourself, then it doesn't really matter. And if you click generate, you have these recommended settings that would be tuned to your specific use case. you have this format for editing the Postgres config file, or you have the alter system commands that you can run from the database. If you run the alter system, you need to do something else to actually have them persist. So yeah, that's the config. We'll use these, but first let's set these three sort of mandatory requirements in the config file. So we have, we need to edit that file, which we need sudo privileges for. So it's etc Postgres, and then 15 main, and now we have the Postgres config file. So here are all the settings, and we can also, okay, let's do these three first. So write ahead level is by default replica, and we want to set it to minimal. But in order for the val level to be able to be set to minimal, you need to set max wall senders to 0, which of course makes sense if you're not using the write ahead. So we need to set this one to 0 as well, and we turn off the synchronous commit. By default it's on. Turn it off, and okay, great. So in order for this to take effect, we need to restart the Postgres service. But yeah, okay. We can do these. We can do the tuning with alter system, and then I'll just change this data directory. So by default, if we look at the config, the data directory is going to be var lib PostgreSQL 15 main. And we want to switch this directory to use the ZFS that we created. So we will want to use a value something like this. So we'll put it in the opt cardano-c node, and then we have the guilddb folder, and then pgdb. So what was this before? In yeah. We can use this. Okay, that, so we changed this setting and the 3 from before. So if we restart the service, so PostgreSQL, and we need to target the 15 service. Oh, it didn't work. Okay. Let's see. What was the error? Operation not permitted. PGDB is not accessible or does not exist. Okay, that makes sense because really it doesn't exist. So we're going to sync the data from the previous directory to this one with the rsync function. So we want to do sudo rsync ravh, and then we want to target the old directory, so PostgreSQL 15 main. That was the data directory before, and we want to set it to opt cardano c node guilddb, and then we set pgdb. Okay, that's copied over. If we go to our c node folder, guilddb, pgdb permission denied. Okay, so we see that Postgres is the owner of this directory, which is okay. Postgres should be the only owner of this data, right? So it has read and write privileges. We can still do sudo ls pgdb, and we'll see. This is how the directory should look like for it to be a valid data directory for Postgres. So it should have files like pg version and so on, everything here. So if we do the sudo system ctl restart Postgres 15 again, now it should restart fine. It does. And if we go to the Postgres database, and we can use the command show to show a configuration setting. So show data directory, for example, and we will see now the data directory is changed. Also, we can check that set show wall level is now minimal instead of replica. So our changes were applied. Okay, I think that's enough for tuning. If you you can also alter these settings with the config file or with the alter system. I leave that up to you. If you use alter system, you need to make some other command which I forgot. Let me see. To make it persist. Not here. It's not here. Okay. This is taking way too long to find. Because it's just a simple command. Okay, internet did not help, but I think I know where it says actually in the, if you go to the PostgreSQL config, and here you have the comments. So this file is read on server startup, and when the server receives a SIGUP signal. You edit the file, you have to do, you have to SIGUP the server, or you need to run pgctl reload or execute select pg reload config. Runtime with set. Okay, so let's just do this to check. Let's just change one of the config values just to make sure it persists on restart. So let's say we take well, might as well take all of them then. We alter system, and we can check max wall size should be 8 GB on restart. So if we now restart the service again, and we go into the database again, and we say show me the max wall size, then it's 8 GB. Okay, so it persisted. And if you tell it show me the mean, it's 2 GB. It persisted. Let's check the work memory, which should be 5 MB. Okay, great, it persisted. So if you alter the system, I guess you don't need to do anything really. If you restart it, it will save. Yeah, but just when you're doing the tuning, just double check that when you change something and you restart the service, make sure that the settings are actually saved. So that's it for setting up Postgres and tuning it. The next step is, of course, to start db-sync. So when we looked at the db-sync binary before, we saw the version is not the one we wanted, which is on the release pages of Koios, which is 13.0.2.1. But in any case, we can go to the db-sync page, back to the db-sync page, since now we have this sample local Postgres server completed. We go to this page, and here we have the instructions on how to run the db-sync. We clone the repository, which, yes, we will need, because I'll show you the next step. So we'll clone the repository to this git directory. And if we are already here. So if you go to this directory, we have all the db-sync repo files here. This is building cardano-db-sync, which we don't want to do because we just need the binary. And now the next steps are basically prepare the DB with the Postgres setup script, which is fine, but and copying the schema over, but we are not on the version we want. So we can go to cardano-db-sync repo, look at the release pages. We can find the release that we want, 13.2.0.1, and we can get the binaries from here. So we have assets, and then we have these binary files, well, tar files, and inside are the binaries. So we can download those, and I have the command here. So I'll use the tmp directory for this. So I'll just get this file. Okay, so now I have this version downloaded. I just need to use the tar command, xvf cardano-db-sync. Okay, that's gonna unpack everything in this directory. And now I just want to replace my cardano-db-sync binary with this one. That's the correct version. So if I do which cardano-db-sync, then it will tell me where the binary is located. So home, Koios, local bin, cardano-db-sync. So all I want to do is I want to copy this cardano-db-sync, or to be explicit, like from this directory that I'm in, this one. I want to copy this cardano-db-sync to this directory, right? Home, Koios, local bin. Okay. Now, if I check my cardano-db-sync version, I have the updated version. Okay, perfect. So we go back to the git cardano-db-sync repository, and then on the docs, on the guild docs, we saw, so after it is built, prepare for cardano-db-sync. Cardano-db-sync needs to create the C Explorer database that it uses to sync the data to. So for this, it has this scripts PostgreSQL setup that we're gonna use. So in this directory, you have scripts, and we have this PostgreSQL setup script. I don't know if it has help. Yeah, usage. Okay. So you can check, you can create DB, you can drop your existing DB. Be careful with that, of course, that will delete everything. list view, create database user, create migrations, run migration, dump schema, and create and restore snapshots. We'll get into that shortly, but what we want to do as the first step is create DB, right? So this says an error, but it's actually not really right. This is a step in the script that's checking, does the database exist? And it's trying to connect to it as a way of checking. And the error is from Postgres. It does not exist. So the next line is all good because the database is created now. So if we go to PSQL and see Explorer, we now have this database that is completely empty, but it exists. So now we are almost ready to run db-sync. There is one more step that we need to do, and that is this linking the schema. So we create a symlink of the schema. The db-sync needs to know the schema from the Git repository to be able to run it. And we just do a symbolic link here because our guild config, the db-sync run config, is expecting the schema to be in this directory, cnode home guild-db schema. So we link these two files together. And yeah, that's it. We can start syncing, I think. Yeah. For this video, I'm just going to show you, so cnode home scripts, and then we have the db-sync script that we saw earlier. So we can just run it and see db-sync start syncing. Unknown migrations found. Okay, well, this is not good. Missing migrations, extra migrations. Oh, yeah. My bad. So you remember how I said that db-sync needs a schema to be able to run? Well, if we go to the, and the schema that we are using is from the Git repository that we cloned. So if we go to the Git and cardano-db-sync, and we do a git status, we'll see that we are on branch master. So the schema on branch master has obviously changed from the version that we are using, which is 13.2.0.1. So we go to this release 13.0.2.0.1, and now the schema in this directory is different. And because it's a symlink, it should be updated where we are using it as well. So important thing that important step that I forgot. So you need to check out to the right version or the right tag or release on the repo to get the right schema for your db-sync version. So if we run db-sync now, it doesn't say anything, which should probably mean it's running. Now I'm gonna cancel that, and I'm going to tail the logs that are created by db-sync in the logs directory, and we see restarting subscription, and basically, yeah, starting. Okay, so basically db-sync started here, and that's fine. Also, if we look at our cExplorer database, we see that now we have some tables created here, and these tables are everything that db-sync is going to give us. So there's a lot of tables, and that's good. It means everything is running. But to sync the whole blockchain would take a long time, and we don't want to do all of that. So we can use a snapshot as well, just like we use for Cardano node, except for db-sync, there is no Mithril. So if you look at the release pages of db-sync, you will find that a release has a snapshot, and you can restore this snapshot by downloading here and using it. Also, Koios, I think it's snapshots.koios.rest. It's not, but let me check what exactly it is. Okay, yeah, actually it is, but db-sync 13.2, and so there are snapshots for mainnet that are constantly updated, and that's fine. But I don't think there are snapshots for preview or for pre-prod. Okay, so right now there's only for mainnet. This is another source of the snapshots, because db-sync creates one snapshot, and it gets old, right? Also, mainnet 13.2 snapshot is missing. It's only for 13.1, and this is 13.2 version. So you can get a snapshot from Koios for mainnet. For pre-prod and preview, it's not there, but I had one of the core members of Koios make a snapshot for me and make it available. So I'm just gonna download it now, specifically for preview network. And I'll put it in the node. I'll make a directory here, db-sync. No. db-sync snapshots. Okay, there's nothing in here, and yeah, so I'm downloading it from this URL, and this is gonna take some time, but not that much. So I'll be able to use this snapshot specifically for preview, and the restoration will be very fast of the whole database. So my db-sync will be on tip fast, and you can do the exact same process on mainnet. You just need a different snapshot, right? So we have this db-sync snapshot file, and the way to restore the snapshot is, see if there's anything in the docs actually. Restoring using snapshot. Okay, there's documentation on the, no, actually here are the commands. There's documentation also on the db-sync repo that you can check. So state snapshot. But yeah, the steps are: download the snapshot that we already did. We need to clear the ledger state from the guilddb folder, because the snapshot restoration requires it to be empty. If it's not empty, it will complain and not work. So this is just a pre-step. And for us, it does exist because we already ran db-sync. We then go to db-sync and we use the PostgreSQL setup script to restore the snapshot. Okay, so I can run this command to remove the ledger state. That's done. So now we are ready to go to the git cardano-db-sync and use the scripts PostgreSQL setup. And now we want to use this flag So we created a DB and we ran db-sync, and it populated some stuff in the DB. So we need to, if we are restoring from snapshot, we need to restore it from a fresh DB. So we need to run recreate DB first. And also, okay, so everything worked here. dropped and recreated, that's fine. And also, the script is a little bit bugged. If we look into what the script looks like, and we search for this, like snapshot, create snapshot, no, restore snapshot. So this function restore snapshot uses pg restore, and then recently this line was added exit on error. And basically there will always be an error, so the snapshot will never complete. We can comment this line out. That would help us the most, because then it will work, because the errors are not critical that will happen. And we can use no owner flag to make the, it's just the nature of the snapshots. They are created with a certain role that owns a database called cExplorer, and then we don't have this user on our setup, so that's where the errors come from. But if we change this, and most importantly, if you just remove this exit on error, it should work, because with exit on error, yeah, it won't really work. There is also, I can show you an open issue about this thing on the cardano-db-sync repo. This one. So you see, restoring from snapshot, role cExplorer does not exist, and the workaround is basically adding no owner. Yeah. So as it stands right now, state of the script is a little bit broken, but here is the workaround. Yeah, so we recreated the DB here, and we are now ready to restore the snapshot. To restore the snapshot, the command is PostgreSQL setup, and then the option is restore snapshot. Now we give it the file of the snapshot, right? So for us, it's Cardano, C-node, and then db-sync snapshots, and then db-sync snap.tgz. And the other argument for this is the ledger state directory. So that's gonna be also opt Cardano C node, and then it's on the guilddb. It's what we recreated here, and then we created this dir C node home guilddb ledger state, and that's it. So if we run this, it's gonna start restoring everything from the snapshot. It's gonna take some time, of course, especially on mainnet. Okay, on preview it's already done. On mainnet this would take a lot more. Pg restore error, but I don't know, I guess that's fine. Yeah, we can always log into the database and see what happened. Well, okay, it didn't work. That's great. It didn't work. Why didn't it work? Why didn't it work? PG restore. Oh, right. Yeah. Because I made an error. There is no output directory for the unzipping of the snapshot, because I did not add a new line here. A new line, I mean this backslash to say that there's another argument on the next line. So this one is commented out, but this tmp dir db is required. Okay, so my bad there. And now if we restore it, the ledger state is not empty, of course. So we need to remove the ledger state and recreate it to be empty. And now we try again. Okay, we're starting again. and we should be getting past that error. So this was the final line before. Oh, okay, yeah, it doesn't work still because I guess it's reading from the next line, which is the commented line. So I'm just gonna remove it. Now this should be fine. Again, we need to remove the ledger state and recreate it, and we restore the snapshot now. Third time's the charm. Okay, so that's the last file from the snapshot to be unzipped, right? And now we are getting past the original error we had. Drop owned, and the data is being populated to the database from the snapshot. All right, it finished. We have some errors here. Now, these are all specific to gRest. So why are the errors here? It's because, so here's where they start. See, schema gRest does not exist. That's because this snapshot, this db-sync snapshot was created from a gRest node. So it does not, it includes extra stuff from gRest, which is stored in this gRest schema. And our database does not have this schema. It only has the public schema created by default. So these errors are from that. So it failed to restore any gRest stuff, which it shouldn't do anyway. That's not what we want. We just want the public schema to be restored. So we can ignore all of these errors, and these errors would not happen if you just restore from a clean db-sync snapshot. Okay, we can explore the database. We see we have the tables created like before, and if we select max ID from block, for example, then we see we have a lot of blocks in the database. And just to show some data, start from block, limit to 1. We just get 1, then okay, epoch. Okay, this is the first block, is like the Genesis block. Let's say 5. We have the hashes, we have the epoch, NOs, and so on. Most importantly, data is synced. So we are finally ready to actually start db-sync, so that besides having the snapshot restored, it will keep syncing all the new data coming from the node. So like we said, again, we can run the db-sync script. Sorry, I'm not in the scripts directory. We can run the db-sync script, but we already ran it. We know that things work. Well, we need to check that it works with our restored database as well, but we can deploy it as a systemd service at this point. And so we use the -d flag, same as with the node. So it creates the service. We can check the status of the service, and it's going to be called cnode-db-sync. So it's loaded but inactive, so we can restart it, and then hopefully everything works. Okay, service restarted, status running. Okay, perfect. And if we look at the logs, and we can pipe the logs to jQuery to have a nicer output. Okay, delaying delete of blocks while rolling back. So I guess db-sync sometimes decides to roll back a bit. That's fine. What else do we have? Inserting Babbage block. Okay, so it can insert blocks starting at epoch 540. This is good news because it means that it didn't start from epoch 0, of course, and our node is on epoch maybe 541. Yeah, but the snapshot is from the previous day. So it would be snapshot is for epoch 540, and that's that's from when db-sync started. So let's get back to the logs, check it a bit more. Setting consistency level to consistent. Okay, that's fine. Inserting blocks. Okay. This is basically it. It might need to do some revalidation of the restored DB on starting, and it may be doing that in the background now. We check htop and we look for db-sync. Yeah, you can see it's using a lot of CPU, so it's definitely doing something that it wants to do. So that's good. Also, this is a good point to check our memory usage. Like we are almost on 7 gigabytes with Cardano-node and db-sync. Again, on mainnet, this is going to be a lot higher than this. But yeah, seems like db-sync is working fine. And yeah, we got past that, past the consistency level log, and now we see we are inserting blocks. So if we go back to the database, select max ID from block, it will give us now a higher number than before, right? If we do it again, a higher number. So it's constantly syncing the blocks that it was missing. And as it reaches the tip of the node, it will continue syncing. Perfect. db-sync is running, database is syncing. This is the prerequisite that we need for Koios, so or gRest. So now we really have everything we need to deploy a full gRest node. And we do that with the setup gRest script. So that's this script, and we can use a -h to see how to use this script. Okay. First of all, the -I is set up components individually, and inside you can select which ones you need to install. So P is for PostgreSQL that I mentioned before. So that's a requirement that we need to install if we don't have it. R is the reverse proxy monitoring layer, which is haproxy. So it's also, we need to install it. Monitoring agent scripts. I don't know off the top of my head what exactly this, but we will install it. And this is C override configs. We don't need it. Override systemd definitions. We don't really need it, but yeah, we can just use. Oh, monitoring agent scripts. Yeah, we don't need them. This is for we basically don't need them to run the node. I'll show you everything you need. So we'll just use this example prcd that's in the help output. We have other flags, -u to skip the update check of the script. -r is to reset the gRest schema, which is like remove everything in the gRest schema. gRest schema is used for all the Koios specific stuff. So all the RPC functions that are used by the API are stored in that schema. All the cache tables are stored in that schema. So if you hit the reset, then it will remove also all cron jobs and triggers. Cron jobs are used by gRest to periodically populate cache tables. And -q is run all DB queries to update on Postgres. So create the schema, recreate the views, the RPC functions, and so on, cron jobs as well. And -b to alternate the branch. So let's try deploying gRest or setting up gRest with this script. And first we're going to use the branch. Well, we need to see. We want to deploy the Koios 1.1.1 RC. So we're going to use this this tag or branch, right? So it's gonna be v 1.1.1 rc rc1. Yeah, rc1. Okay, that's the branch we want to deploy. That's what we were aiming at from the start. We need to install the components, so prcd, Postgres, haproxy, and we'll overwrite the settings and systemd definitions. Do we need anything else? Yes, after everything is done, we can use the -r, which will reset the schema and redeploy everything fresh. We could just use -q, but you can use -r for a fresh deployment every time. Okay, it did not find this branch. Okay, it's not rc1, it's just rc. My bad, I got confused. rc is the tag, and it's not. Okay, now I am confused. Do I have a typo? I don't. Okay, let's have a look at the release pages. I see. Yeah. Okay. Yeah. So this is the branch on the Koios artifacts repo, but actually what the setup gRest script is targeting is the guild operators repo. And here the branch is Koios dash 1.1.1 for RC. Okay. So that was the mistake. This branch needs to be Koios. Okay, script update detected. Yes, update. Okay, and now the script is going to install Postgres, haproxy. This might take some time. Yeah, what else? It's going to deploy the services that will need to restart. It's going to deploy the cron jobs. And yeah, keep in mind you should only be running setup gRest after your db-sync has synced at least to close to the tip, right? Don't run it before, because it will just slow everything down, or it might not even work. But since we restored the snapshot and we saw the db-sync is on the same epoch that that the node is, then everything's fine. Okay, so after it installed the services like Postgres and haproxy, now it is adding the gRest schema and it's deploying the views. So these are all the endpoints that Koios provides. Okay, some things are just indexes and so on, but most of these, like account endpoints, address endpoints, asset endpoints, these are all being deployed now. And the cron jobs we'll see are maybe at the end, or they're already deployed before this. But you see there's a good amount of functions, and each function corresponds to an endpoint. Yeah, so here are the cron jobs from the cron scripts. Yeah, everything is successfully deployed, everything's fine. Okay, restarting Postgres. So we can see sudo systemctl status, and then we have two services from gRest that we need to care about. So we have Cardano-node, cardano-db-sync, and now additionally we have Postgres and haproxy. So haproxy is not running right now, and let's see, Postgres is running. It was restarted here by the script. So PostgreSQL is running, haproxy is not, so we'll just restart haproxy, cnode haproxy, and now this is running as well. Okay, so how do we know that everything is working? Well, we can, of course, ping our own instance. So localhost or like 127.0.0.1. Then, okay, I forgot the port number, but it's 805. So yeah, port numbers. 8053 is going to be do I have this? I do. Okay. 8053, it's going to be the haproxy service. 6000 here is the node. These are node. 8080 are the stats, and 850 is PostgreSQL. Okay, so PostgreSQL, haproxy. haproxy is a proxy to Postgres. So here we can query Postgres directly, and we just need to know an endpoint. So if we go to the API page of Koios, and we can take some simple endpoint of information, even something, yeah, get tip. So to query the Postgres directly, I think it would be curl 850 and then RPC tip. Yes, works. Okay. So the response is the tip, which is like we can do it on the API page as well. And we have this endpoint that gets us the tip, the hash of the block, the last block, the epoch number, absolute slot, epoch slot, and so on. And if we want to, but this is querying directly Postgres, right? Which is, which you can do, but we also want to query the haproxy. And if we query haproxy, then we use port number 8053. And then I guess it's API v1 tip. Yes, okay. So this is a slightly different URL, but basically follows everything from the docs here, except the endpoint is now different. We are now targeting our local machine. The cron jobs will be stored in etc cron-d. Yes. So here we have a list of cron jobs that are created, and we can look at some of them. So cnode active stake cache update, for example, we'll see that it runs every 15 minutes. Every 15 minutes, it will execute these this cron script active stake cache update, and it will write a log to the logs folder. So if we go to the logs, we'll probably see some of them have already run. Yes, like pull history cache update, asset asset info cache, asset registry, and so on. Now, how does, at the start of this video, we looked at the presentation and we saw Koios looking at instances, polling them, and seeing which one is healthy and which one is not. So how is that decided? This, you have a convenient script here called check status that will give you some overview of what's going on. So you have the Postgres local and it's up, right? So this means your instance is healthy. Our instance is healthy right now. The failover is where the request is redirected by haproxy. If you query haproxy, if you query Postgres, if it's not working, it's not working. But if you query haproxy and your node is not healthy, then it will automatically fail over to the Koios SSL, which is the Koios cluster, right? So I'm running a gRest node here. Imagine that I make a request to my own node. The node is not healthy. My request will be automatically forwarded to the network, Koios network cluster, and I will get a response from one of the nodes in the network there. So a very nice feature to have. Koios also supports Ogmios and Submit API that we did not set up here. We are just concerned with the database. But if you look here, you see Ogmios query example. So we could run Ogmios as a service as part of Koios, but I'm not covering it in this video. And also transactions. I'm not sure. There should be an endpoint for submitting a transaction, but I don't know. Maybe it's not here. Anyway, we are not running these services, so they are down because nothing is running on these ports that they should be running, that haproxy is assuming the service should be running on if they are. So check status script, and the question is, this is saying this is up. How does it know it's up? What goes on in the background is there this script gRest poll, which is executed on the gRest nodes, and this is the script used by haproxy to constantly check the health of the node. And here is the check update of the script itself. That doesn't matter. Check version. So here is the check version. It executes some queries against your instance and against the monitoring instance, the live. And if it's a match, then fine. If there is no match, then it's gonna be here. It's checking the version, so it's a version mismatch. Then it checks the tip of the node to make sure that your node is syncing and on the tip. If it's not, then it will print an error like it did not provide a timestamp that's within 300 seconds or whatever. It checks the RPC structure so that all the endpoints you have deployed are what should be deployed for this version of Koios. It has the check RPC. Okay, this is just part. These two functions are working together to check the same thing. And it checks the Koios cache status so that if your cache jobs have failed, the cron jobs or anything like that, then your instance will be considered not healthy. It checks that the limit of Postgres, the setting is set correctly. It checks a lot of things, and basically that's how it's determined that your node is healthy or not. That's it. So now with this setup, you have your own Koios node that you can set your own limits to, and you can query it directly. If you go to files, you will see an haproxy config file. Now this may be a bit hard to read, but it's the file where all the rules for networking are located. So you have some default settings here, and then mainly you have the front-end app, which controls with this use backend to basically redirect the requests to the appropriate backends based on here the path variable, the URL path, so beginning with, and so on. What we care about, I guess, is our gRest Postgres, our backend for the Postgres service. And this is the one that we saw as up, but actually you see that by default, this external check command that's using the gRest poll script that we saw is commented out. So normally Koios node is a part of a cluster, and the monitoring service, which is the top level DNS, executes these checks against the nodes. So you can comment this out, and then this haproxy service will perform the gRest poll check on your own node as well, but this is actually disabled by default. So if you save this and restart the haproxy service, you will be executing the gRest poll external checks, but there's no need for it. And yeah, then the local server for this backend is the 8050, the PostgreSQL port. You have the gRest failover defined here, which is the server that goes to the preview.koios.rest. And you have the Ogmios that we saw that we didn't set up now. You have the submit API as well that we didn't set up, and so on. So that's the haproxy file. With this, we are now at the end. You have everything set up. You can query your own instance like we saw through haproxy like this, or through directly through Postgres like this. And that's it. Good luck setting up your nodes. If you ever need help, there's a link to the Telegram support channel, the Koios support channel, and you can get help with anything related to Koios or the guild documentation or anything you need. You can always go to that channel and get help from a lot of good people there. And that's it. Yeah, good luck setting up the node. Good luck playing around with the Cardano data, and see you in the next video.